perpendicular distance from a point to a line. So if the general equation of a line is represented as ax plus by plus c, please don't be confused. This is the same as what we've been doing, just that it is in a different form. So it's y is equal to mx plus c. But if you bring everything to one side, it becomes mx, right, plus y plus c, which is the same as ax. So the equation of a line can be represented as ax plus by plus c. That means the equation of every line can be represented as a number, right? A is a variable, multiplying an x plus another number multiplying a y plus a constant. That's the equation, general equation of every line. So with this in mind, and then if we have a point with, in this example, they use h and k. I will use x and y. Right. If I have a point xy, so I choose to use xy. You can use any variable. Then let's say we have this line and then we have this distance, right? And there's a point here. This is a point P, X, Y. So the line, this is the line AX, AB, sorry. So this is line AX plus BY plus C. This is just A goes with X, B goes with Y, and then plus C. Then the perpendicular distance, this is what we want to find. Perpendicular distance is like the shortest distance, you see. It could be a line from here to here, a line from here to here, a line from here to here, a line from here to here. Amongst all these lines, the shortest will always be the one that is perpendicular to the line. So the perpendicular distance, also known as the shortest distance between a point and a line. So we want to find this distance. Right, so this is the distance we're talking about. This perpendicular distance is what we want to find. This distance from here to here, we want to find this distance. So that is what we'll be finding here. Right, so the formula for perpendicular distance is plus or minus ax plus by plus c over square root of a squared plus b squared. This is very simple to memorize, right? It's very easy to memorize because it's just the equation itself divided by the coefficient of x squared and then the coefficient of y also squared, right? So a squared, that's the coefficient of x, then plus the coefficient of y also squared. This is very simple. So let's see. So let's see how we use it. So we have to memorize it, so I'll put it in a red bar. So please memorize this formula. Yes, start it. So when a point, the perpendicular distance from the origin is taken as positive, points on the same side of the line give the same sign. So if these points, so I see it has positive and it's negative. Sometimes it's positive, sometimes it's negative. So if it's positive on this side, then it's negative on the other side. If it's negative on the other side, it will be positive on this side. So if points are on the same side of the equation of the line, then they will have the same point. So if another point here, Q, so if this Q has positive sign, right, it's plus and minus. If it's plus, then P will also be plus because they're on the same side. It means those on the other side will be minus. That's what that means. So points on opposite sides of the line have different signs. Let's take example 1. In example 1, find the perpendicular distance from a point. So in example 1, find the perpendicular distance from a point. The point is 2, 3 to the line. The line is 3x plus 4y is equal to 5. Find the perpendicular distance from this line to this point, right? So we'll use our formula, plus or minus ax plus by plus c over square root of a squared plus b squared. What's a? From this equation, a is 3. So we have 3. What's x? X is this 2. Plus b. What's b? 4. What's y? 3. Is equal to 5. Wait. We can't make it equal to 5 there. So, we should convert this so that it becomes minus 5. Right. So this is equal to 5. We will take 5 to the other end and make it 3x plus 4y minus 5 is equal to 0. So that's what we have here. So minus 5. Then we will divide by square root of a squared. What's a squared? A squared is square root of 3, right? So 3 squared plus b squared. What's b? 4. So 4 squared. Let's see, we have 6 plus 12. That's 18 minus 5. That's 15. 15 over square root of 9 plus 16. That's 25. That's 5. So the answer is 5. The answer is 3. Wait. 18 minus 5. 18 minus 5 is 13. 18 minus 5 is 13. So the numerator is 13 over 5. So that's the answer. 13 over 5. That's the distance from the line. That's the distance from the line to the point. 13 over 5. You can leave it in fractions or convert it to decimals. So 13 over 5. Right. It's 13 over 5. So it's 13 over 5. You can choose to make it positive, you can choose to make it negative. You shouldn't really worry about the sign. You can just leave it as positive. The signs come in when we are asked to find the distance of two things, right? Distances cannot be negative. But if I measure the distance from my house to school and then I make it positive, then the distance from my school to my house becomes negative because it's in the opposite direction. But distances don't have it. Don't have a sign. Just that whenever you use square roots, there's either a positive or a negative, right? Whenever you have square roots inside of this function, the answer of a square root is always plus or minus, right? So that's why there's a plus or minus. But don't worry about plus or minus. Forget about it. Just leave your answer in positive. All right, let's take another example. Example 2. In example 2, show that the points this and this are on opposite sides of this line. So we want to show that these points are on opposite sides of this line. If points are on opposite sides of the line, then they will have different signs, right? One will have a positive sign when I measure the distance from that point to that line, and then the other will also have a different sign. So if the first has positive, the next will have negative. The distances will not be the same, right? Because they didn't say the distances are the same. So maybe this is the line. The line is x plus 2y is equal to 6. There's one point here which is 1, negative 1, 2, and there's another point here which is 3, 4. Right? In the actual sense, it's supposed to be the other way around. So they didn't tell us the distances are the same. All they want us to find is one should be the sign of the other, the sign opposite sign as the other. If this is plus, this would be negative. If this is negative, this will be positive. So let's see if this is true. So in case A, we'll have the distance from the first point to the line. So that's let me do d1. D1 is equal to ax, right, plus by plus c all over a squared plus b squared, all put in the square root. So that will give me a. What's a? A is 1 because the square root, the coefficient of x is 1. So 1. What's x minus 1? What's b? B is here 2. Then what's y? Y is 2. Plus c. What's c? C is minus 6. I see in it. It's 6 here, but I will have to send it to the other side so that it becomes ax plus by plus c. So c becomes minus 6. What's square root of a squared is 1, right? It's negative 1 squared, so it's negative 1 squared. Then b is 2, so 2 squared, right? So we'll have 1 minus 1 plus 4, that's 3. Then 3 minus 6, that's 9. So that's minus 9. Wait. That's minus 3. That's minus 3. That's minus 3 over square root of 1 plus 4. That's square root of 5. So this is the answer for D1. Let's see D2. D2 will have the same formula. The only difference here is we'll have x and y coming from the next point, right? So a is 1. The first point is 3 plus b. X is 3. Y is now 4. Plus c. What's c? It's minus 6. Over square root of what? A squared. What's a? A is 3. What's b? 16. Oh, 4 squared. Yeah, that's 16. So 4 squared. If we simplify, we have 1, 3, 3. B here is 2. Sorry. B is 2. B is 2. B is 2. B is 2. So 2. 3 plus 8. That's 11 minus 6. That's 5. So we have 5 over 5. Alright, it's 5 over 5 over square root of 5. No, 5 over 5. Then I'm making a mistake somewhere. Yeah, I'm making a mistake here. It's 5 over, this is A and B, right? A from here is 1, and then B from here is 2. So I made a mistake by substituting 3 and 4. It's supposed to be 1. So 1 and 2. That's square root of 5. Right, so you realize that this one has a positive sign, this one has a negative sign. That means, so since they have, right, so look at how they concluded. Since these distances are of opposite signs, the points are opposite sides of this line. So since they have opposite signs, right? So that's how you find it. Then so you should try the other examples. Example 3 here. Show that the point this is a reflection of the point this in the line this. Right. So if a line is a reflection of another line, for a mirror, when something reflects on a mirror, the image distance and object distance are the same. That means that in this example, not only are we going to have positive on one side and negative on the other side, right? Sorry. Not only are we going to have positive on one side and negative on the other side, right? It's positive here and the negative here. We are also going to have the same distances. So you should find the distance, right? The distances should be the same. So in the end, you conclude that since the product of the gradient is equal to -1, which means that like the gradients are the same, but one -1 of the other, right? Right. So that's the idea here. So a point is a reflection of the line given by if and only if one, the given line bisects AB, right? So the line should bisect AB means that the distance from one point to the line and the line distance from another point to the line should be the same. 2. AB is a perpendicular to the given line, right? So if it's a reflection, Then AB, right? We can find a line AB, and that line AB should be a perpendicular to it. So if I pass this test, then I pass this test, then I pass the midpoint of AB, right? So that's how they pass the mid test. So the way you show that points are reflection, one point is a reflection of the other. Is one, it should have opposite signs. When you do it, you get opposite signs, just like we did. And then apart from being opposite and having opposite signs, they should have the same distance from the mirror. In this case, our mirror is the line, the equation of this line. This line is the mirror. If this is a mirror, if I put something here, it should give me the same image here. The distance from my object to my mirror should be the distance from my mirror to my image. So we'll find the distance here, that's the perpendicular distance we just did. And we'll find the distance here, they should be the same, just that they should have opposite signs. And then you conclude that since they have the same sign, different sign but same magnitude, they are reflections of each other, right?